This lesson that we're going to take a look at today is going to be entitled Parts of a Term, and it's going to specifically look at polynomials and how we can break up a single term into different specific pieces. So to start off with, we're going to take a look at a polynomial. And again, as we remember from the previous lesson here, a polynomial is made up of one or more terms. These terms are then added together to make up the entire polynomial. Each term is made up of numbers, letters, and exponents. Okay, those are three things that are made up of, and we're going to look specifically at what each one of those is and give specific names to those as well, not just numbers, letters, and exponents. The thing is, not all of them need to be here. Some might be a 0 or some might be 1. Then we don't necessarily always write them, depending on what we're looking at or looking for. Now, each term has some very specific parts. The first one is something called the coefficient. Okay, the coefficient, okay, this is the number that is in front of the variable. So if we have a variable, okay, a letter, and we'll get into variable, that's the next one we're actually looking at, and I've kind of I'll define it already here, but when we look at the variable, there's often a number in front, and if there's not, we're going to assume that it's 1, and we'll take a look at that in just a little bit. But that is what we call the coefficient. Okay, the number is called a coefficient, and that's what we're going to be referring to it as from now on. The second thing, as was mentioned, is the variable. Okay, and this is the letter that's a part of the term. Now, as you saw in the last lesson, we have a number of different kinds of letters that we use. We often use X, sometimes Y, sometimes other letters as well, but the variable is that letter, and so there's a specific letter that's been used, and that is what we call the variable. Now, we can have multiple types of variables or multiple variables, so we could have an X and a Y, but those are called variables, okay? And so each letter is a different variable. The final thing that we could have is what we call an exponent. Okay, and this is that small value that's on top of the variable. Okay, and this will only be on the variable. It does not apply to the coefficient, it only applies to the variable. Okay, so if that's x, it's x squared or x times x. We don't apply it to the coefficient in front, we only apply it to the variable. Now, if a term does not have a variable, but only a number, which we're often calling coefficients, but no variable, this term is called a constant. Okay, this is because it has no variability. Variable, something like that, I think so. Yep, it has no variability, meaning it's not going to change. Okay, it will be the same value always. Okay, it doesn't change, it's a constant. It's set at a certain number and it will not change from there. A variable means that the value of the term will change based on the value of the variable. A constant is going to stay exactly the same no matter what. Let's take a look at an example of a term, and we're going to list out the three parts of this term. So for the term 5x squared, we're going to determine the coefficient, the variable, and the exponent. Now in here, this part right here in front, the number, is our coefficient. So our coefficient is equal to 5. Now, in front of the 5 is going to be whether it is a positive or negative, and in this case right here, it is a positive number, and so the coefficient is positive 5. If there's a negative in front of it, or a subtracting sign, then the coefficient would be negative 5. Now, along with that, our variable is x. Okay, our variable is x. We're using the variable x in this case. It's not x squared, that's not the variable. The variable is x. Okay, so we're using x, and if we knew what x was, we could solve this. But our variable is just x. And finally, the exponent is 2. And we're going to get into exponents a little more right away here. Okay, so our coefficient is 5, our variable is x, and our exponent is 2. Now, if there was nothing in front of the x, okay, so no number, our coefficient would be 1. Okay, so that'd be important to remember, the coefficient would be 1. If there is no exponent over the x, the exponent is 1. Okay, so if there is nothing in front of the x, so if we have something, and I'm just going to add in another example, so something like, let's just do y. Okay, for y, the coefficient is 1. And the exponent equals 1, and our variable equals y. So our coefficient is 1, and our exponent is 1. And so those ones we still need to include in there. We can't just say they're 0. They're not 0. They are 1. All right, so I just need to quickly scan down to my notes here. The exponent has another description and describes the full polynomial. So if we have a polynomial with a number of terms, the exponent, or at least the largest exponent, is going to describe that polynomial. The exponent of the variable is also referred to as the degree of the term. Okay, it's referred to as the degree, and we're going to call it the degree from now on. Okay, it is an exponent, and we'll say exponent, but it's the degree of the term. And the highest degree in the polynomial is considered the degree of the polynomial. So if we have more than one term, the biggest degree of those terms is going to be the degree of the polynomial. Now, if we look at our example that we had above there, 5x squared has a degree of 2, okay, as the exponent of the variable is equal to 2. Okay, so those are going to be the same thing, degree, exponent. They're going to be related to the exact same thing. And so, again, there's only one term. It's a monomial. And so because it has a degree of 2, the whole polynomial has a degree of 2. I'd like you to fill in the chart for question 1 and 2. Question 1 involves taking a term and breaking it up into coefficient, variable, and exponent. And question 2 gives you these 3 pieces, and you have to make a term from there. Okay, so work on questions 1 and 2.